Okay, page 2. Page 2 of Unit 3 review. Let's continue. So there's going to be 3 separate videos. This will be the second video. Okay, more of solving equations. So I'm going to give you lots of these. Even though there's only about 6 of these on the test, I'm giving you, on the front page we had 6, 7, 8, 9, 10, 11, 12. I'm giving you 14 of them to practice, but there's only going to be like 6 of them on the test. I just want to make sure you guys are ready for any type. All right, so this one is going to be type 1 from the front, which there's logs on one side, so you will swoop. But before you can swoop, we have to condense the left-hand side because you have to get it to a single log on the left-hand side. So when you see subtract, we are going to divide the x plus 4 and the 9. So you're going to write log base 3 once, and we're going to divide x plus 4 and 9, set this equal to 1. Do you guys understand that step? Condense the left-hand side. Now we're going to do the swoop. So we're going to go 3 to the first equals x plus 4 over 9. Multiply both sides by 9, or if you want, just put that over 1 and just think of it as cross multiplying. So we have 27 equals x plus 4. 3 times 9 is 27. 1 times x plus 4 is x plus 4. Since we're solving for x, we're going to subtract 4, and x is 23. 16. What type is this? This is when you have bases that cannot be the same. So this is case 4 on the front, which means to take the natural log of each side. So when you have bases that can't be the same, you take the natural log of each side. So I'm going to take the natural log of e to the 2x minus 5 equals natural log of 4. What that does, I'm going to put parentheses around this and bring this out front. So we have 2x minus 5 out front, natural log e equals natural log 4. Who remembers from the other day what natural log of e is? Natural log of e, if you do this, natural log is natural log second divide. Natural log second divide brings this up. And remember that that's 1. So this is really 1. So I don't really need this. And 1 times 2x minus 5 is 2x minus 5. So really just it goes away. Solving for x, inverse operations, add 5 to both sides. So we're going to have natural log of 4 plus 5 equals this 6.38623 or whatever, 6863. And then we're going to divide both sides by 2. Divide both sides by 2. And the final answer is 3.1931. 3.931. So again, on the calculator, I press natural log of 4. And it's very important that you close the parenthesis here. Plus 5, and then I divided by 2. All right, this one. Get your family paper out. I need to get my family paper so you guys can see. This might be one of the ones that you can get to be the same base. Sometimes you're not sure if you can. You look at the 6 family. If you look at the 6 family, do you see the 216? It's in there, 6 cubed. So that 216, this is going to be case 3 or from the front. When you could get them same base, same base. If you have the same base, you're going to drop the bases. But before you can drop them, you have to get them to be the same. So this one, first of all, 216 is 1 over 6 to the third. Okay, again, we looked at the sheet right here. 216 is 6 to the third, but it's in the bottom. So if it's in the bottom, we can put it in the top as 6 to the negative 3. At this point, we're going to drop the bases. Drop, drop. Set your exponents equal. Set exponents equal. Drop basis. Set exponents equal. Okay, so we're going to add 1, and x equals -2. X equals -2. I like that one. You guys like that one? All right, 18. This one has logs on one side, so you cannot drop the logs. In order to drop the logs, one has to be on the left and one has to be on the right. There's nothing on the right, so we're not dropping the logs. However, we are going to condense this to a single log on the left-hand side. So write log once, and because it's a plus, we're going to multiply x and 5. I'm going to write that so that x times 5 looks weird like that, so I'm going to write it as 5x. It's the same thing. Now, what do? This is case 1. When you have a single log on one side, you swoop. But you can't swoop unless you know the base. What is the base? Hopefully you're yelling 10. So fill in the 10 because that's a common log. It's 10 squared equals 5x. 10 squared is 100. And then divide by 5, and x is 20. X equals 20. All right, this is also case 1. We're going to swoop. We have a single log on the left-hand side. What's the base if it says natural log? If you're not sure, if you look at the natural log key, and right above it, you see the E? That's the base of natural log. So it's E. So put an E in there. So when you swoop, it's E squared equals 2x plus 3. I'm switching from red and blue. Subtract 3. So it's E squared minus 3 equals 2x. And then divide by 2. So x equals all of this. Let's punch it all in at once. So E, to punch in E, you have to press second divide. Second divide, and you're going to square that. Then you're going to say minus 3. Now I'm going to press equals here to get this to be one number before I press divided by 5, or divided by 2. Because right there it says E squared minus 3 divided by 2. So I have to get all those to be one number before I can press divided by 2. So once, see, that's all one number now. Now press divided by 2. 2.1945. So again, be careful when you have something like this. If you have two numbers like that, you need to get this down to one number. So sometimes it's better to put the top in parentheses if you don't want to get that down to one number. That if you do parentheses, then divide by 2, you don't have to worry about that. But if you don't use parentheses, make sure you press equals after E squared minus 3. Press equals, then divided by 2. All right, what is this one? I think this one is case 3. I think we can get these to be the same base. Now, if you don't want to do case 3, you never have to do case 3. I can take natural log of this right now, both sides. You can always take the natural log of both sides. But sometimes it's fun if you can put them in the same base. I see a 2, and I believe that 256 is in the 2 family. There it is. 256 is 2 to the 8th. See that? There's the 2. They're in the same family. So 256 is 2 to the 8th. So what can we do? We can drop the bases. So if you drop the bases and set these exponents equal, set exponents equal, solve for x, x is 1/2. 8/16 is 1/2. Punch it in the calculator if you don't know why 8/16 is 1/2. I'll take 0.5 for an answer. This one's got a lot of logs, This is case 2. This is the drop the log case. Drop the log from each side. But before you can drop, you can only drop 2. One from the left, one from the right. So what do we do first? First step is to condense. Because this is subtraction, we are going to be dividing. Because of the subtraction, we are going to be dividing. So write log once. Take x plus 4 and divide it by x minus 3. Set it equal to log base 5. So our first step was to condense. Second one is to drop the logs from each side. So once you have a single log from each side, drop the log. take x plus 4 over x minus 3 equals 5. And we're going to cross multiply. So this is x plus 4 equals, I'm going to distribute 5 with x minus 3. So that's 5x minus 15. I'm going to write that up here. I'm out of room. So x plus 4 equals 5x minus 15. I'm starting up here. All right, how do I get x by itself? How about we subtract an x to this side? How about we add 15 to this side and divide by 4? Since 19/4, I would take 19/4 as an answer. Or you can punch in the calculator and get 4.75. I like that answer better. 4.75 is 21. So 21 was that doozy. Whoops. All this is 21. Okay, so for the challenge problem here, this is a challenge problem. When you have two numbers that have the same base and you're multiplying, you add the exponents. So you take 2x plus x. So that's going to be 4 to the 3x on the left-hand side. So I need to change 64 to base 4. I think I can do it. Here's 64. 64 is really 4 cubed. So I'm going to change this to 1 over 4 cubed. So the left-hand side, I had to get these to be 1 base 4. So I added the exponents and got 3x. On the right-hand side, I had to write 1 over 4 cubed. And that is going to end up in the numerator as a negative 3. Because anytime it's in the bottom, it can be moved to the top as a negative. Drop your bases, and x equals negative 1. So it says, these are the directions on the next page. So I'm done with page 2. So I'm going to stop.